In this lecture, basically we will discuss about the Large Hadron Collider LHC. You already know it's the world's largest and the most powerful accelerator at CERN in France and Switzerland. This experiment has a huge circumference, okay, of 27 kilometer in circumference, okay, which is located in CERN, in which there are basically four detectors. Okay, one is the CMS, the other one is LS, the third one is Atlas, and the fourth one is LHCb. These four are the four detectors. Okay, and these operates an unpredicted energy level, okay, to study fundamental particles. As I told you in my previous lecture, to study about the fundamental particles, you must have to accelerate your particles approximately equals to the speed of light. So at CERN, specifically at LHC, we accelerate particles and with an energy of nearly equals to speed of light. Yes, because you know that by Einstein's equations, energy equals to mc square. Okay, by applying high amount of energy when the particle collides, all the energy is converted into mass, some mass. So whenever the particle collide, after collision, many other particles generated which have some mass m. Our work is to study dead decay products, dead particles of the universe that we don't know yet. Okay, so this is the overview of LHC which is going on. In this, first of all, we have to take two protons and we have to accelerate both protons into the opposite direction of this circular circumference, and that protons and have to collide at, okay, in this, and have to collide at different detectors, okay, like ls is working on some other aspects like atlas, lscb, and cms. These particles collide here in these detectors, and these detectors detect their respective things which they have to discover. Okay, what's this role in high energy physics of LHC? Basically collides proton at nearly speed of light, as I told you, which we have to recreate the conditions for the Big Bang. How we are doing so this? Because we want to study that what's basically how the Big Bang occurs. We are going before this. Okay, so we are checking this. We are studying their decay products, and after knowing the decay products of dead particles, we have to move backward, and going backward, we want to study what happens at the Big Bang. Okay, the next, it allows physicists to study particle interaction, means how particles interact with each other. Okay, and then we will discuss their further aspects, like we discuss their multiplicity, their pseudo rapidity, and their pt means transverse momentum. Physicists also study their jet production, because you know that whenever the particle collide, they have to now then move, they have to make jets. Okay, how jets produce. So physicists are doing work on this, and to study the fundamental forces, as we already studied about the fundamental forces in our previous lecture. You can go through by watching that video. Okay, and the last key for this discovery is like the Higgs boson. Basically, the Higgs boson is also discovered at LHC. Okay, how this discovered? Basically, what's basically the Higgs field? Higgs field is the field which given mass to all elementary particles. Okay, so this key for discovery for the Higgs bosons, and you can say by understanding the jet dependence of the particle productions. We have to study the jet dependence of particle production whenever you have to jet on, jet off, or either jet default. Okay, so this is all about the Large Hadron Collider. Okay, you can see by this diagram. First of all, we have to initialize our two beams. First of all, we have to move our two beams into the booster. After going to the booster, then our it circulate in circular part. It increases the speed of the two beams of the proton. Then it moves towards the proton cyclotron PS. Okay. After particle accelerating many in this chamber, it moves towards to the SPS, super proton synchrotron. Okay, SPS, super proton synchrotron. It moves your beams very fast, and after that, finally, your beam now move towards the LHC, Large Hadron Collider, your large circular circumference, which is about 27 km in circumference. And this experiment is basically going on 100-meter depth from the ground, okay, in France and Switzerland. So this is, and then after in the LHC, your particles collide respectively at your different detectors like CMS, LS, ATLAS, and LHCb. So this is all about the LHC. Okay, so thanks for watching. Stay tuned with us. We will upload more lecture for particle physics. So stay tuned with us. Thanks for watching. Allah Hafiz.